First example, question 1. So here you have a histogram. Here you have 1, 2, 3, 4, 5, 6, 7 bars, 7 graphs. Part A of the question says, how many classes do you have? Okay, you know that each bar represents one class or one bin. 1, 2, 3, 4, 5, 6, and 7 classes or 7 bars. Second question says, estimate the frequency of the class with the least frequency. What's the meaning of least frequency? So it means that the repetition or the count in that class, in that bin, is the lowest. It means that you have to select the smallest bar. So the first bar seems to be the smallest bar here. The representative or midpoint for the first class is 24.5, but this is just a representative. What is the frequency? Frequency is on vertical line. So you have to estimate the frequency, which is almost, you can say that it is roughly 15, 20 maybe. Best estimation, best approximation. You don't have exact value, just estimate. The frequency, the count for the class with the least frequency. The frequency is on the vertical axis and it is roughly 15. Part C says estimate the frequency or the count of the class with the greatest frequency. The greatest frequency, it means that you have the highest repetition in your data. Very well, we have to select the largest bar. Our largest bar is this bar. The representative is 54.5. We don't need the representative, we don't need the midpoint. We want to know what is the frequency. What's the count? So the count or frequency on the vertical axis is going to be 300, roughly. Part D says, determine the class width. The class width. Okay, since you have the midpoints of two classes, you only need to subtract consecutive midpoints and get your class width. So to find class width, we can say that very well. The representative or the midpoint for the second class is 34.5. The midpoint for the first class is 24.5. If I do the subtraction, it's going to be 10. So the class width is 10. You can take any two consecutive numbers, do the subtraction, and to find the class width. Part E says, what is the mean? The mean of your collection, very good. So we know that the mean or balancing point or the center is a number in the middle of your horizontal line.
I knew it.
So if you look at the shape of the graph, it's not very skewed. It's almost symmetric. So the balancing number is going to be a number in between. What is that number? Okay, you can say that it's roughly 50. 50 is the center or the mean of your collection. Let us move on to question 2. Okay, question 2 says, here are the daily withdrawals in hundreds of dollars for 30 days from an ATM each day. So you have a collection of numbers. Question says, use inner quartile range to find any possible outlier. Okay, perfect. First, we need to find first quartile, then third quartile. In the next step, we need to find inner quartile range, which is Q sub 3 minus Q sub 1. In the next step, we multiply inner quartile range by 1.5. Any number in the collection less than Q1 minus inner quartile range times 1.5 is a possible outlier. Any number greater than the third quartile plus inner quartile range times 1.5 is a possible outlier. So you can use your calculator. You can go to stat, then go to edit, then enter the data in L1, for example. Then you go to stat again, you go to calc, one variable, and enter. You can find all the data and information related to those data in your calculator. Okay, let us enter these data. Find quartiles. I'm using an online calculator. Okay, here we have a sample. So let me share my screen, show you. You can use different calculators. For practice, you can use online calculators. This website is called Alcula. So you enter the data, you put a comma next to them to separate these numbers from each other. Since we are working with a sample, instead of selecting a population, we're selecting a sample. Okay, next number, 97, 82, 84, 67, 70, 81, 82, 89, 74, 73, 86, 81, 85, 78, 82, 80, 91, and 15. Okay. So lower quartile or Q sub 1 is 75.5. Q1 is 75.5. Let us find Q3, 86.5. So we're done with the calculator. Now we have to do the algebra. Q sub 3 minus Q sub 1, 86.5 minus 75.5. As you can see, your inner quartile range is equal to 11. In the next step, you multiply inner quartile range by 1.5. 11 times 1.5. $16.5. Okay. In the next step, you have to calculate Q1 minus 16.5. Okay, Q1 is 75.5 minus 16.5. In the final step, we have to calculate Q3, 86.5 plus 16.5. So any number less than 59 in the collection is a possible outlier. So let's look for any number less than 59. Do we have 58? Do we have 57? Do we have any 50 in this collection? Nope. Do we have any 40? Nope. Do we have any 30? No. Do we have any 20? No. In the range of tens, we have 15. So 15 is a possible outlier in this collection. Next, any number greater than, okay, now we have to do a little bit of calculation. Any number greater than 103 can be a possible outlier for us. Greater than 103. Do we have any number greater than 103? Yes, we have 204. So these are our outliers in this collection. Next question, question 3. Very well. So what do we have here? So score of 84 on psychology or score of 74 on economics, which one is better? Okay, perfect. Take a look at the mean of the psychology. It is 88. Standard deviation is equal to 7. So let me put economics in a box and psychology, just underline these values. First of all, the z-value, the measure of position, is x minus mean divided by standard deviation. So let us write z of p representing the z-score of psychology. Your x value, which is your test score, is 84. The mean is 88 and standard deviation is 7. On the numerator, if you do the subtraction, you get minus 4 over 7, which is roughly negative 0.5. So roughly negative 0.5. What about economics? Your score is 74, the mean is 63, and standard deviation is 5. So z of econs, 74 minus 63 divided by the mean, which is equal to 11 over 5, which is about 2. Okay, so we want to know which score is better. It means that which one is toward the tail on the right-hand side. So remember that when you have a normal distribution, the mean of the distribution, 0 is located in the middle. This is your center. Which is 0. 1 standard deviation, 2 standard deviations, 3 standard deviations, -1 on the left-hand side, -2, and -3. Okay, -0.5. This is the z-score of psychology, which is around the mean, around the rest of the majority of the students who scored about the mean. But take a look at the z-score of economics. It is 2, which is here, ZE. It means that it's better than ZP. It's toward the tail. It's around the percentage, 10%, 20% of the students who got good grades, very good grades. So this portion here shows the students on the top 10, 20% of the class. Very well, so the answer is economics. So if it was a negative number on the left-hand side, then the score is among the students who did terrible on the test. So some of you did the algebra, and instead of having +2, you had -2. If your score is -2, it means that you are on the lower bracket in the class. The students who did terrible on the test. So this is students who failed the test. So sign is very important. When it's positive on the right-hand side, we're happy. Happy face. I got a good grade. When it's on the left-hand side, it means that you're sad. You need to study more. Next question is question 10. Very well. You have a bunch of numbers here. And the question says, find the 5 number summary. Minimum, maximum, first quartile, second quartile, third quartile. Then find the inner quartile range, Q3 minus Q1. Draw a box and whiskers plot. And then about how many motorcycles fall on or below the third quartile. Okay, so here we have to use our calculator. We have to do a little bit of calculation here. So let us select this data. Let us go to Alcula. For you, you're going to use your calculator. Okay. Let's enter the data here. And let us separate these. Be careful not to skip any number. Perfect. So we're done with these numbers, and as I mentioned, it's just a sample. Submit the data. Lower quartile, Q1, 81.5, okay? 81.5. Second quartile, or the median, is 91. Q2 is 91. Q3 is 99.5. 99.5. Okay, 5-number summary. What's missing? The minimum value is missing and the maximum value. Okay, if you use your calculator, it gives you the minimum and maximum value, and you don't have to look for the data in this collection. So it seems like the minimum value in the collection is 68, and maximum value in our collection, let's say, is it 114? Yes. So these numbers are the answer to question for part 1. Part 2, it says find inner quartile range, which is Q3 minus Q1. So 99.5 minus 81.5, which is 18. Now to graph this, we just need the minimum value, the maximum value, a little bit of scaling, 68, and the maximum 114. So here, suppose this is the middle one. Let's say it is just 90. Then here you have 100, 102. And here you have, for example, your 80. Okay. Again, using a calculator, it just creates everything for us nicely. Minimum value, and we stop at first quartile. Then we form a box. So our first quartile is 81. So let us move this guy a little bit, or just write this as 81. So 81.5. Then the last quartile is 99. So let us stop here. Then we continue the whisker. And our second quartile shows the median, which is 91. This is our graph. Now it says about how many motorcycles fall on or below the third quartile. Where is third quartile? Third quartile is here, 99.5. So 99.5. So how many data are above 99.5? Is this the majority of the data? Then you can subtract these, because you know how many data do you have in your collection. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 25 data in the collection. So how many numbers are above 99.5? So here you have 100, then 101, 111, 114, 103, and 112. 1, 2, 3, 4, 5, and 6. So 25 minus 6 is going to be 19. Next question. Question 5. So here you have categorical data. The question says, consider the following frequency table and form a pie chart. Very well. So the first step is to find relative frequency. It means that you have to take the frequency of each category and divide it by the total frequency. 180 divided by the total frequency, 210 divided by the total frequency. So we have to add all of these values together. So 570 plus 40, 610, 180, 790, and 210, 1,000. Okay, perfect. So if you cancel out 0 and 0, you get 4%. 1010, 57%. 1010, 18%. 1010, 21%. Very well. So contacts, 4%. It's the smallest one. So we can just divide this to 57%. 57%, which is for eyeglasses. Then you have 21% non. 21% non. Then you have 18% contacts and eyeglasses. So 18% contacts and eyeglasses, and 4% is just for contacts. This is our pie chart representing this categorical data. Very well, the definition. As I mentioned before, you have to have the definitions on your cheat sheet. You need to know the definitions. Definitions are very important when it comes to math. You depend on definitions. So what is an outlier? An outlier is a value which is far away from the majority of the data. You could just graph it as well to show that if we have outliers in the collection, then we get skewed graph. Or you can just use a box plot, show that outliers in a box plot are denoted by dots. So suppose this is your box plot. These dots representing outliers. For measure of center, you can define measure of center by defining the mean, mode, median. For measure of spread, you could talk about the range, inner quartile range, variance, and standard deviation. Okay, let us move on to the next question. Find the range, mean, variance, and standard deviation of the following collection. Very well. You can use our calculator. Okay, let us find calculator here. Calcula. Here we have a sample. Let's enter the data here. As I mentioned before, your calculator doesn't calculate the variance for you. You have to calculate variance after you find standard deviation. Okay, standard deviation, sample size is 14. The mean is 6.86. So let us write this down here. So mean is 6.86. The range, which is defined as the maximum value minus the minimum value, can be calculated. 15 maximum value in your collection and 1 minimum value in your collection, which is 14. Now, your variance is equal to standard deviation squared. So standard deviation is 4.77. 4.77, this is our standard deviation. Now variance, to find variance, you have to do a little bit of algebra yourself. Variance is standard deviation times standard deviation, or standard deviation squared. So let us just multiply this number by itself. $22.75. Variance 22.75. This is the variance of your collection. Very well. Again, you have a collection of data, weekly salaries in dollars for a sample of high school teachers are listed below. Find the mean, median, and mode of the salaries. Which one best describes a typical salary? Is this mean, is this median, or is this mode? Very well. Let us calculate the mean. Let us enter the data here. So median seems to be, let us add the text here for you. This is your median. Let us find the mean as well. Okay, here we have our mean. So this is your mean. Okay, which one best describes the collection? Do we have any mode here? Do you have any repeated number here? Mode, there is no mode. So no mode. Okay, which one best describes a typical salary? Do we have outlier here? If you had outlier in your collection, then median was the best. So with outliers, median is a typical value. Now look at this collection. It doesn't seem to have outliers in this collection. So you can say that median or mean best describe a typical salary or the center for the collection. So you can either use median or mean. Let us move on to question 9. Which one is quantitative? Which one is qualitative? So remember that quantitative, quantity, numerical, it means that you can do algebra. You have meaningful algebraic operation on your data. Qualitative, categorical. No meaningful algebraic operation on categorical data. The first one says the ages. Okay, of course it is numerical or quantitative. The second one says zip codes. Even though zip codes are numbers, we don't have any meaningful algebraic operations on zip codes. If we add them, subtract them, multiply zip codes, there is no meaningful outcome by doing algebra on those numbers. So it is categorical. Then you have revenues. Of course, you can find the typical revenue numerical. The marital status, married, single, and so on, categorical. And finally, social security numbers. Again, even though these are numbers, there is no meaningful algebraic operation between social security numbers. So it is categorical. Very well. Let us move on to the next question. Okay, here you have a collection of data. Part A says, find the percentile that corresponds to an age of 40 years old. First, you have to write these numbers in the format that you can actually count all the numbers below 40. Let us rearrange these. What's the smallest value here in the collection? What's the largest value in this collection? So let's see. 28. Do we have any 20 here? I don't see any 20. What about 30? We have 35. Okay, do we have any other 30 here in this collection? I don't see any 30. What about 40? Okay, we have 40, 140 here. Then we have 41, 141 here. Then, okay, I lost this, okay, 38. Then do we have any other 41? Nope, 42. Oh, we have another 41 here. Okay, so 42, 142 here. Any other 42? Let's look for everything. Nope, 43, 143 here. Any other 43? Yes, I have 43 here. 44, okay. It seems like I have one. Oh, another 43. I lost this one. 3 43s. Then 44, 144 here. Do we have any 45? 45, I don't see any 45. Oh yeah, it's here. It was hidden. Then any 46? 46. Nope. What about 47? Yes, I see 147 here. Do I have any 48? Yes, 148 is hidden here. Then, okay, any 50? Yes, I have 150, another 50 here, another one here, 3 50s, 1, 2, 3 50s. Do I have any 52? Doesn't seem like to have any 52. What about 53? Yes, I have a 53 here. 54, 154 here, 154 here, so 54 and a 54. Then, guys, I forgot about this 47. There was a 47 hidden here, so we have a 47 and a 48. So 47 and a 48. Okay, where were we? Do we have any 55? Nope. Do we have any 56? Yes, 156, another 56, so 56 and 56 here. I have another 56. Okay, perfect. Then do I have any 57? Yes, I have a 57 here. So let us write this 57 down here. Next, another 57, perfect. Do I have any 58? Nope. Do I have any 59? No. Do I have any 60? Nope, but I have two 61s. So 61 and 61. Then 65, perfect, and a 66. 65 and 66. Very well. To find a percentile that corresponds to an age of 40, we need to count all numbers less than 40. Divide by the total number of entries in your collection. Then multiply it by 100. Okay, how many numbers are less than 40? Less than 40. 1, 2, 3. 3 divided by how many data do we have in our collection? We have 30. And we multiply it by 100. 10th percentile. Part B, find the percentile that corresponds to age 56. So to find the percentile, you count all numbers less than 56. You divide it by the total numbers of entries and you multiply it by 100. Less than 56. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 divided by 30 times 100. You can cancel out a 0 and 0. 21 divided by 3, 70. So you get 70 percentile. So the majority of the data fall below 56. As you can see, it's 70%. Perfect. For C and D, it's actually just the opposite. The percentile is given, so 75th percentile is given. You need to find that missing value, x, the total number of values, less than the given value, so you can write it as a question mark, divided by the total number of values in your collection is 30, and then you multiply it by 100. So you can simplify this. You can cancel out 0 and 0. Your question mark is equal to 3 times 75 divided by 10. If you simplify this fraction to 5, you get 2, 13. So you have 39 divided by 2, which is 19.5. The closest number to 19.5, it's going to be like 20 if you round it up. So which ages are above 75th percentile? Remember that this number, which you can round it to 20, shows the count in your collection. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, the age is going to be 54 and above. So the age corresponds is 54, and since it says above and above. And the last one, 25th percentile. So your percentile is given. You're looking for that missing count divided by 30 times 100. You can cancel out a 0, so that missing count is equal to 3 times 25 divided by 10. You can simplify this to 2 to 5. That question mark is 15 divided by 2, 7.5. We can round it up to 8. So this is the count below 25th percentile. 1, 2, 3, 4, 5, 6, 7, 8. So age 42 and less. the answer to part D of the question. So we're done with the exam